Hi.
Oi, so they give access to their job portal, Geeks for free?
Yes, complimentary with the course.
And you got your job through that?
Me and 15,000 others across the world.
No way!
Oh, yes, Wiz. Don't delay. Enroll now.
Geeks learning together.
Hi, and welcome to Geeks for Geeks. Today, we would be discussing yesterday's problem of the day, that is, minimize the sum. So, can I have a quick yes in the chat if I'm visible as well as equally audible? Hi, Rishit. So, I would quickly just share the tab, let you recapitulate the question, and then we would move forward to solve this question. Today, we won't take much time, at max 10 to 15 minutes, because the problem is an easy problem and the idea is not even that great difficult. Like the transition from the brute force to the optimal solution is easy to crack. Hi Priya. Okay, so I think you're done. Okay, so I would unshare my screen and share the whole screen of mine. Okay, so in this question what you are given is, just let me remove this. Yeah, so in this question, you are given an array of n elements. Okay. And what you need to do is at each step, you need to select two elements. Okay. Get the sum of two elements. Then you need, in the next rigorous steps, you need to have the sum at this point, and then the sum is also inserted in the array. Like suppose there were 1 2 3 4 5, then first suppose you select 1 and 2. So in the next step you have the sum as 3, and now the array would be the sum of 1 and 2, that is 3, and then 3 and then 4. So basically the two elements would be replaced with one element, which is the sum of that two element, and the sum, which is the running sum, or you can say, because it is quite akin to that. So that sum would contain the sum of that two elements that you have selected. Okay, moving forward to this, what you need to do is you need to minimize this sum. Okay, am I clear with the problem statement? Just give me a quick one in the chat, because explaining the test cases would reveal the solution. Just give me a quick one in the chat. Okay, so the mentor is also coming. Hi Suniti. Okay, just give me a quick one. Okay, Rishi, thanks a lot. Others? Okay, fair enough. We will move forward. So now if you see this problem, the problem is, like, I would just explain you the test cases, then it would be very easy. Yep. So if we move here, you would see that this sum, how it is given. So see, 1 added to 4. So now we have 5. Okay, we have the sum as 5. Now 5, 7 and 10. Now this is the current one. Now in the next step, we would have select two elements, that is 5 plus 7, and this would, we would add 12. Now this would become 17, and this would become 12 comma 10. Now the next step, we would select these two elements, that is 22, add to it, and this would be 39 itself. This is how this total sum 39 is there. So now if you see that if we want to minimize the sum, then basically that first element that is added. So if you just see the contribution of this, so basically this is known as contribution technique in programming, but still I would just explain you the intuition behind it because the intuition is equally important. It is because that suppose this one is being carried at all step. Like see, if you just see one here also, the sum it is contributing again. Then again, this 4 is also contributed again and again. Like see, this sum initially it has 5. In the next step, it is 12. In the next step, it is 22. In each of it, we have the sum contributed again and again. So initial contribution, जो पहली contribution है हमारी, we start off with that, we keep up with that. So it is just like this example that suppose we have inculcated a habit in our childhood, that suppose a bad habit is being like suppose I smoke. So suppose I have been smoking from my childhood, so it just means that I'm carrying it. So I need to be very cautious among what habits do I take up. In the same manner, if the initial values are very important and it is being carried away to each iteration, then to minimize the global value, we need to have the global minimum too. Like it is just like the greedy algorithms definition that we make greedily or local optimal decisions to make the global optimal decisions. Okay, so fair enough. So if we take this value small, then we have 1 1 1 1 1. If we take this value 10, then it is not greedy approach. Basically it would have a loss, like this 10 is being carried away. So this just gives us a conclusion that the initial elements should be as small as possible. So basically at each step we should select the smallest two elements, and then we would move to the highest element, so that the highest element would have the least contribution and the smallest element would have the maximum contribution. Am I clear till this point? Just give me a quick one, and then I would explain you the algorithm. Now the idea is, while you're just telling me, okay, the idea is that at each point you want the smallest element. So just I'm giving you the constraint, and then the solution would be very prominent. The first is that we want the minimum at each step. Okay. The next is the elements are dynamic. Elements are not fixed. So basically we are given an array, we would just sort it, and then we would have the minimum element which is situated in the first and the maximum element which is situated at the back. That won't happen because because the elements would keep changing. Okay, like the new sum that we are getting, it would be replaced. So we need the two things that we need to do is we need to delete elements, we need to insert elements, and we need to get the minimum. So if we have this thing, that these three things, okay, get minimum, okay, delete the minimum, and push new element. Okay, and if you write down all these conditions and the requirements, then basically it's nothing else than a priority queue. Okay, if the elements were not changing, if we didn't want any modifications in the static elements, the elements are static, then we can just simply sort it. But here the elements are changing, so we need a different data structure to prioritize it. If the elements are unique, you can use a set. If you can also use a multi-set to have it, but I'm moving forward with priority queue. Okay, the very next question is that the default priority queue or the easy one. Like if you just see, there are two kinds of priority queue: min heap and max heap. Okay, what is a min heap and a max heap? A max heap is basically where the first element is the largest one, and in the min heap the first element is the minimum one. Very simple, very evident from the name itself. Now moving forward to this, what do we require here? We require a min heap, but the default declaration of priority queue gives us the priority queue of max heap. So now the syntax of max heap. Now if you just say C++ syntax of max heap, like if you just see it, like just or let's priority queue. Let us write priority queue C++ STL. Okay, so if you just see this, then the simple priority queue is very easy to say that priority queue of int, but this would implement a max heap. But the min heap syntax is a bit difficult and it is very hard to remember and it is not intuitive to be honest. So what you can do is you can do a cunning approach that you remember the default priority queue, and if you want a max heap, then it is okay. But if you want a min heap, what you can do is before inserting, just multiply it with -1, and after taking out, again multiply with it with -1, so that you don't need to search it again and again, and you don't need to remember it again and again. So max heap priority queue can be converted to a min heap, and in the same manner min heap can also be converted to a max heap by just multiplying it with -1, and with, after taking out, multiplying it -1. Why? Because let us take the very few, like minus like 5 and 1. Okay, so if you insert this in a max heap, the structure would be like this. But if you multiply everything with -1, then the structure would be like this: -1 and -5. And after taking out this 1, if you multiply the same thing with again -1, it would become 1. So basically this is how we are getting it. Just do it on a pen and paper and you would get the intuition. Now moving forward, how we would solve it. Okay, so we would just initialize a priority queue, insert the elements. Every time we would take the small elements and we are good to go. So now let us just start implementing it, and if you face any issues, I would do that. So stop sharing, share the tab. Okay, I'm a very lazy person as well as a competitive programmer, so I would make things as ARR to A and okay. So priority queue of integer and name it as PQ. Then we would move forward to for int I is equals to 0, I is less than n, and I plus plus. Okay. Now at each step, we would push the negative of the element. So PQ dot push negative, okay, like negative -1 multiplied by A of I. We are good to go. And then we would initialize simple long answer. Int would also solve the purpose, to be honest. Okay, so now we would say we have said that we need to do this process again and again till we have one element. So we would say while pq dot size is greater than 1, like if there are more than one element we would do it, less than one element we would just discard it. Okay, so now we would say long a is equals to negative -1 multiplied by pq. As I told, before inserting it into pq dot top, before inserting it into the priority queue, we need to multiply it with -1 c. After taking out, multiply it with -1, and then max heap is converted to min heap. Now pq dot pop itself. Okay, so we are removing the element. Okay, now we are taking the second element. Okay, so I would just make it the b itself, b done. Okay, now we would say long sum is equals to a added to b, and then again pq dot push -1 multiplied by the sum itself. Okay, and then answer added with sum, because it would get carried away. At the end we would just return the sum. Okay, now let us just compile and run and see how many errors are we making. Okay, so we need to return the value of answer because it is a local variable. Yeah. Okay, we are good to go with the sample test cases. Now let us see how many, if we can get an AC. Okay, fair enough. We got an AC. So now this is the solution itself. Please see to it. If you face any issues, just tell me the line number. Straightforward. Okay, wonderful explanation. So if this was from a student, I would be happy, but this is from a mentor who is my colleague, so I'm not. that great app. Bhaiya, my DSA is not cleared. Study, bro. How to do DSA strong? Okay. Study more. Okay. Straightforward problem. Yeah. Candy Hundi C. Yeah. Okay. पढ़ लो भाई पढ़ लो. Okay. Anything more you have to ask about? Line number 21. Yeah. So we are just told that we need to keep this process ongoing till we have the elements greater than 1. So that is what we are doing. Okay. So I think every test case is catered. Okay. So that was it for today from my side. So if you face any issues and this video is streamed a lot back, what you can do is you can connect me over LinkedIn if it is important, and you can ask me. So if you're watching this stream in the recorded version, feel free to just comment or like the video so that this work could be justified. Thanks a lot.